Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, in this video we shall continue with tangents and intersecting chords, and we are getting into 18C part 2. The exercise is slightly big, so I have broken it into three parts. First part we did in the previous video, second part and third part is in the next video yet. So tangents is a good topic. Most important property of this chapter, I'm discussing it over and over again. Angles in alternate segments. What is it? So inscribed angle theorem, if this arc AXB is 60, then this angle will be 30, half of it. Yeah, that's from the circle chapter. From this chapter we got tangent secant theorem. That means if this arc is 60, this angle will be 30. Merging these two is this one, angles in alternate segments. That means if this arc AXD is 60, this will be 30 by this property, and this also will be 30 using this property. Therefore both the angles will be equal, that is ABD will be equal to ADC, angles in alternate segments. So I hope you remember this property and how to use it. Mountain and the valley is what is the easiest way to understand. So let's hit it with second part, sum number 16. They want you to prove that angle ACD, so ACD is right over here, plus angle BAC is this one. The total of these two should be equal to 90, and O is the center of the circle. So let's name this point as point E. Okay, and I'm giving you the clue, connect EC. There the clue is there with you. EA is the diameter, therefore what will happen? Come on, 90 degrees somewhere. Yes, ACE will be 90, angle formed in a semicircle. That means if this is 90, that total of these two also will be 90. This plus this is 90. This is what you need, but this you don't need. Instead you need this. Can you prove these two equal? Trump. Yes, angles in alternate segments. So this will be equal to this, and therefore you can say this plus this 90, so this plus this also 90. So how will you write the step? We went reverse way, reverse logic. Now how are you going to present? So step 1 should be angle AEC equals to ACD, angles in alternate segments. Step 2, you can say that EA is a diameter. Step 3, therefore angle ACE is 90 degree, angle formed in a semicircle is a right angle. Step 4, therefore CEA plus CAB is equal to 180. Plus this one equals to 180, angle some property, substitute this as 90, remove it out, and then remove this angle and substitute this in that, and you'll get this plus this 90. Let's write it. If you can, great. If you cannot, don't worry, I will write it for you and you will be getting it. So let's begin. Step 1, we will say angle AEC is equal to ACD, angles in alternate segments. Yeah, very important this step, we shall use this later. Then we will say EA is the diameter. So if EA is the diameter, then we can say angle ECA 90 degree, angle formed in a semicircle is a right angle. Please write complete statement. Right now I am not writing it. Now we get into the triangle ECA, and we say that angle AEC plus angle ECA plus angle EAC equals to 180. AEC can be written as ACD, ECA can be written as BAC, this one. So ECA is 90 and EAC can be written as BAC, same name, equals to 180. Reason will be from some statement number 1, 3 and 5, because we substituted this and we substituted 90. Final step, therefore angle ACD plus angle BAC, 90 goes on the other side, so is equal to 90. Simple. The sums are not tough, but you should know your properties well. If you know the properties well, it's going to be very simple. Yeah, I have put the list of all the properties in the description for this chapter, so please go through them, put it on your softboard so that you learn it well. Let's go to the next one. Sum number 18. Come on. 18 is a good question. It's not that simple, so you will have to be with me constantly. They have given you AC equals to AE. Alright, CP equals to EP is your first target. CP and EP, that means this and this. So if you want to prove CP equals to EP, if I join EC, there are 2-3 different methods. Okay, so if I join this, if I prove base angles equal, then isosceles will give you this equal. That's one method. Second method, take this triangle BPC and DPE, opposite triangles, prove the two triangles congruent. So CP equals to PE and BP equals to DP. Simple. But to prove these two triangles congruent, you need 3 parts. So part 1 can be this equal vertically opposite. Can you get the second part? Got it? Wow. Can I say this angle equals to this angle? BCD, BED, angles inscribed in the same arc are congruent. And third part we'll get, don't worry. Just be with me for 3 steps, then you can start on your own. So I will say BC and DE intersect outside the circle in point A, and therefore if two chords intersect outside, what's the property? Do you remember? Perfect. AB into AC, AD into AE. But AC equals AE given, so what will happen? If AC equals AE cancels, AB equals AD. AB equals AD. Now AB equals AD. If I take this step 4, okay, and step 3, and if we subtract, see, AC minus AB will give us BC, and AE minus AD will give us DE. So these two. If we get the third part now for these two triangles, that is the side. So see how easily we are able to connect and create a web in order to use these properties to prove what we want. And now I can prove these two triangles congruent easily by AAS test. Yeah. The other method is getting this, which is a lengthy method. I'm not getting into it. This is enough, I believe. So let's subtract. Now you can pause the video, start on your own, subtract, get these two, and then 5 golden steps and do it. Okay. So AC minus AB equals AE minus AD. Subtracting 3 and 4. So when I subtract, what will I get? AC minus AB will give me BC, and AE minus AD will give me DE. So we got this as the major part. Let's jump into the two triangles. So in triangle BPC and triangle DPE, these two triangles, we'll first say angle BPC equals to DPE, vertically opposite angles. Let's take a fresh sheet and move about with the second part. So 3 more parts to go. Let's see how can we present them. So statement number 9. Angle BCP equals to DEP. Angles inscribed in same arc are congruent. And then the last part, BC equals DE. From statement number 6, BC equals DE. So from 6. 11th, therefore the two triangles BPC is congruent to triangle DPE by AAS test. Now that your triangles are congruent, we can say CP equals EP. We can also say BP equals DP. Both the parts, reason will be CP, CTC. That's what we wanted, and both parts are there. Yeah. Other method, if you're curious, pay attention. I'm not repeating it. You're going to say BC equals DE. Once you reach to this step number 6, then you will say congruent chords subtend congruent arcs. Yeah. And then congruent arcs subtend congruent angles on the circumference. So for BC, the angle is AEC, and for DE the angle is DCE. So you get base angles equal isosceles, and therefore PE equals CP, and you get the first part. Yeah. And then for the second part, you'll have to say BP into PE equals CP into PD. Chords intersecting inside. CP equals PE, so these two automatically equal. That's a slightly technical method. This is easier method. So I thought I will do this one. Let's go to the next one. Sum number 20. This is 2011 board question. You've been given this as 30 degree and O is the center. First target BCO. Come on, who's getting this one for me? Congruency. Use it. Prove the two triangles congruent and get this one for me. Think about the three parts. Pause the video. 5 steps of congruency, 6 steps CP, CTC, and you get BCO. Come on. I will see you after 6 steps. Please don't copy. So, step 1. In triangle OAC and triangle OBC. Let's see what are the parts. I will say OA equals OB. Radii of same circle. Yeah. I'm sure the first part you must have got. Even second part you must have got. OC common side. So at least 2 parts are sorted. What about the third part now? So AC BC. Tangents drawn from exterior point. Tangents drawn from exterior point to the same circle are congruent. So this is equal and common side. Right? And therefore we can say triangle OAC is congruent to triangle OBC by SSS test. Once the triangles are congruent, it's very simple. Simply we can say angle ACO equals BCO equals 30 CP CTC. So we managed to get our first angle 30 degrees. Now the next one is AOB. So here also we'll have to be little smart. This full is 60. We are trying to work on this quadrilateral AOBC. This is 60. This is going to be 90. Tangent. This also 90. Angle sum property, easily I can get AOB. Isn't it? So come on. What are you waiting for? Step 7. First say that OAC equals OBC equals 90. Reason will be tangent drawn at any point on the circle is perpendicular to the radius through that point. I hope you learned that statement by now. And now jumping into the quadrilateral OACB, directly I can say AOB 360 minus 90 minus 90 minus this 60. So my last step for this part AOB, how much will that be? 120 degrees. So we got this one as 120. Finally they want APB. So this is 120. How much? Come on now, this is the easiest one. 60. Angle at the center, double the angle on the circumference. So let's write step 11 onwards. Angle AOB, double of angle APB. Angle at the center is double the angle on the circumference subtended by same arc. Purposely I wrote this entire statement so that you happen to learn it, and this is from the previous chapter if you remember. So now AOB is 120 divided by 2 APB. So finally I can say therefore angle APB 60 degrees, and that's what we wanted the second part. So all 3 parts sorted, APB done. I hope you are getting these sums, yeah? Because you know the properties well, therefore you are doing it so well. Let's go to the next one, sum number 22. Put a star besides it, it's a very good question. So I want everyone to please focus on this question with me. Do not try and go ahead, otherwise you will not be able to get this one. Okay, they say prove that ONL, that is this angle here, and OML, this angle here, the total is 180. Now what we'll have to do is we'll have to find each of these angles in number itself. It's given that ABCD is a square. So we know that for a square all angles are 90 degrees and the diagonals bisected. So this is 45. Further, they have also told us that this is a bisector here. So the other part also is 45 And since this is a bisector, this will be 22.5, 22.5. Likewise, on the third side, this pole will be 90 but bisector, so 45. And this is further bisector, so each will be 22.5. Yeah, half of 45. But our target is this angle. So what we'll do is we'll take triangle BNA and find this angle with angle sum property and then say vertically opposite angle. Also diagonals bisect at right angle. So we'll take triangle AOM. This is 90, this is 22.5. We will get this angle in number. And then we'll add these two angles to show that it is 180. That's the only way to reach here. Okay. So please be with me. Do not try and go ahead. Otherwise you will get confused. So how are you going to minimize the step and still present your sum very well? So pay attention. Quadrilateral ABCD is a square, and therefore diagonals bisect the angle. So we'll say therefore angle ABD is equal to DBC is equal to BAC is equal to DAC equals to half of 90, that is 45. And the reason will be mentioned is diagonals of a square bisect its angles, and therefore each is 45. So now once we've got this 45, then you can get this each angle half of it. So we will further say angle ABN is equal to DBN is equal to this one, that is angle BAN equals to angle DAN. Wait one second, not BAN but this one, this angle over here and this angle over here, that is DAM, this one, and the other one is this one, that is MAO. All of them will be half of 45, that is 22.5. Reason will be since these two are bisectors, that is BL and AM. So since AM and BL are bisectors, so we managed to get all of them as 22.5. Yeah. Now wherever we want, we can jump into those triangles. So let's jump into this triangle BAN and get this angle. So in triangle BAN, angle BNA is equal to 180 minus 22.5 minus 45. So 45, 67.5, so 112.5. And then we'll say vertically opposite angle. So BNA, this one, is equal to angle ONL equals to 112.5 vertically opposite angles. So we managed to get one of the angles that we wanted. Likewise, we'll try and get OML. For that, we are going to take triangle AOM and say this is 90 and then proceed from there. So let's pick it up. So we are starting with step number 7 now. So step 7, in triangle AOM, okay, we'll say angle, this one, that is OML, equals to 180 minus 90 and minus this 22.5. And you can write reason since angle AOM is equal to 90, diagonals bisect at right angle. So we mention all the reasons. Finally, we'll get OML 90, 22.5, 67.5. Now, ONL plus OML is what we want. So ONL is 112.5 and OML is 67.5. So we shall add these two and finally we can say ONL plus OML is equal to 180, and that's our first part. So we managed to get this one. Yeah, a lot of mehnat you have to do with this one, but the second part is simple. Prove that BAM equals to BMA, these two angles over here. So you already have them in value. This one we just found 67.5 and this one you can add and get 67.5. So come on, let's get the second one. Pause, you can try this on your own. BAM is 45 plus 22.5, 67.5. And for this one, BMA is directly 67.5. From BMA is OML, one and the same. So from 9. Finally, we can say therefore both the base angles are equal. That is BAM equals to BMA equals to 67.5. And therefore triangle BAM is an isosceles triangle. And since it's an isosceles triangle, therefore we can say BA equals BM. So second part sorted. BA equals BM. We are still not done. Oh sorry, I wanted the angles over here. So we got the angles here itself. So why did I prove this? These two steps are not required only. So sorry about it. So let me cancel them. And let's go to step 15 again. Now, this is the most important part. ALOB is a cyclic quadrilateral. Now, cyclic quadrilateral can be proved by 3 methods. Listen. Step 1 or method 1. Prove that opposite angles are supplementary. Method 2. Prove that exterior angle of the cyclic quadrilateral is congruent to its interior opposite angle. 2 properties we know. And property 3. Prove that angles are inscribed in the same arc. What do I mean by this? That means if this is a cyclic quadrilateral, let's say ABCD, then this angle should be equal to this angle. That means ABD should be equal to ACD, and then you can say since these two angles are equal, they are inscribed in the same arc. If they are inscribed in the same arc, that means all 4 points lie on the circle, and therefore this is a cyclic quadrilateral. That's what we are going to use here. So pay attention carefully. ALOB is a target, correct? So if I look at this carefully, LAO is 22.5, LBO is also 22.5. So both the angles are inscribed in the same arc, and therefore we can say this is a cyclic quadrilateral. So let me magnify it so that we can understand it really well. This is A, B. Here you reach to point L, come down to point O, and then connecting it to point B. Correct? This is one angle and this is the second angle which we are targeting at. Our target is to prove that ALOB is a cyclic quadrilateral. That's over here. This much part which I am magnifying right now. Right? So if you look at this, LAO is 22.5, and if you look at this, LBO is also 22.5. So since both angles are inscribed in the same arc, therefore they are equal, or since they are equal, they are inscribed in the same arc, therefore this becomes a cyclic quadrilateral. So my step 15, directly I will say angle LAO is equal to LBO is equal to 22.5. Therefore, angle LAO and angle LBO are inscribed in same arc. And since they are inscribed in same arc, no more reasons required. Directly I will say ALOB is a cyclic quadrilateral. Got it now? Very important sum. That's why I took extra time and expanded this part separately to make you understand how to go about with this part. Yeah. Repeat this sum 2 or 3 times in the video and you will get a good hand on it. Otherwise, it's going to be a nightmare. Next one, 21. They say 3 circles externally touching each other. CR is the radius of this circle, BR radius here and AP radius here. You need to find all the radii of the 3 circles. 6, 8 and 10 is already given to you. So how are you going to find the radii? So we'll say let CR equals CQ equals R1. Likewise, BR equals BP R2. And AP equals AQ R3. So R1, R2 and R3. So we managed to get all the three names for the three radii. Now pay attention carefully. Step 1. I will say AB plus BC plus AC. So AB is 10, BC is 8 and AC is 6. AB is R2 plus R3. Come on, take it forward and let's see where do you reach now. Discover something. BC R2 plus R1 and AC R1 plus R3. Pause and try. 18 plus 6, 24. So I will get 2 times R1, R2, R3. I have pulled out 2 common as 24. So therefore I will get R1 plus R2 plus R3 as 12. Now, but R2 plus R3 is how much? Look at the diagram and answer. R2 plus R3 is 10. R2 plus R3 is 10 and therefore R1 plus 10 is equal to 12. So I can say R1 is 2 centimeters. So we managed to get the first radii. Likewise, but R1 plus R3 is how much? Look on the diagram, you will get R1 plus R3 is 6 and therefore step 9. If R1 plus R3 is 6 plus R2 will be 12, therefore we will get R2 as 6 centimeter. That's your second. And now for the third one, but this time we will take R2. Now we want R2, right? R1, R2 we got, so we want R3. So R2 plus R1, that is 8. So we will say therefore R2 plus R1 is 8 plus R3 is 12. So we will get therefore R3 as 4 centimeter. In the end you can write the final statement. Therefore the radii are 2 centimeter, 6 centimeter and 4 centimeter. Interesting, isn't it? We did this time in the first exercise of tangents, if you remember. Let's go to the next one. Oh, I did 22 first and then I did 21. Alright, I'm trying to do maximum sums here so we get maximum advantage. Sum number 23. Come on, let's begin. You've been given this angle as 140 and your first target is PAB. Simple. Pay attention carefully, you will get it. This is a semicircle. So first complete it as a circle. So our vision becomes easy. This is the diameter because O is the center. So this angle becomes 90. Angle formed in a semicircle. If you want this full angle, this is 90. You need only this part. Come on, it's very simple now. Very good. You still didn't get, I'm giving you the hint. There you go. This is a cyclic quadrilateral. Opposite angles are supplementary. So this will be 40. 40 and 90 will give you this one as 130. That will be your first one. So come on, let's write. If you can pause and write on your own. So you can say PQ is a diameter. No short forms in the exam. Therefore angle PAQ 90 degree. Reason will be angle formed in a semicircle is a right angle. So we got this 90. Now for the second part, we will say BAQ plus BCQ 180. Opposite angles of a cyclic quadrilateral are supplementary. Please learn all these properties. Now BAQ we don't know, but BCQ is 140, so 180. Finally we can say angle BAQ 40 degrees. So this is 40, this is 90. So final part PAB, what you want is 90 plus 40, that is 130. So we managed to get our first angle PAB. Now for the second one, AQB, which is right over here. And they have given you PA equals AB. So congruent chords, come on, subtend congruent arcs. And congruent arcs subtend congruent angles, right? This full is 130. Can I take PABQ as a cyclic quadrilateral? See, all 4 points on the circle, correct? This is 130, so I will get this. Then I will say both angles are equal because chords are equal, so each will be 25 because 130, so 50 and then 25. So I will get AQB as 25. So come on, let's write AQB. So I will straight away say first angle PAB plus angle PQB equals 180. Opposite angles of cyclic quadrilateral. Please complete the statement. Therefore, PAB is 130 plus PQB 180. So I will get PQB as 50. And now we will try and prove that these two angles are equal once we get PQB. So to get the angles equal, we are going to use chords. So we will say step 10, chord PA equals chord AB given. Now if chords are equal, arcs are equal. So we will say arc PA equals to arc AB. The reason will be congruent chords subtend congruent arcs. Yeah, are we okay till here? Now congruent arcs, these two will subtend congruent angles on the circumference. So let's take a fresh sheet and let's go about it. So our next step, step number 12, we will say angle PQA is equal to angle AQB. Congruent arcs subtend congruent angles on circumference. So we got the angles on the circumference equal this time. And now we are getting into the last part. AQB straight away we will say. Therefore AQB is half of 50, that is 25. So we managed to get our second angle as well. Now for the last part, prove that AO is parallel to BQ. This we got 25, this we got 25. If I want to prove AO parallel to BQ, see over here I am pulling out AO and BQ. So AO, QB. If I want to prove these two parallel, I'll have to prove these two angles equal. This is already 25. Can I prove this 25? Yes. Join OQ. Come on, I've given you the clue. Radii of same circle, this is already 25 base angles equal. So let's write the last part. I will say in triangle OAQ, OA equals OQ, right? Radii of same circle. Therefore angle OQA, OAQ both are equal to 25. Then we will say angle OAQ equals to AQB equals to 25. And since these two angles are equal, they are alternate, therefore AO parallel to BQ. A reason should be alternate angles test. See, when parallel is given and you're using the angles, you say alternate angles. When you're using the angles and proving parallel, you say alternate angles test. So that's our last part. Good question. Let's go with the next one, 24. 24 is not that difficult. I'm pretty sure you can manage this. QTR is the first angle we need. These two lines are parallel. This is 20 and this is 100 already given. So to get this one, we'll get this angle, linear pair, and then we can say angle at the center and circumference. Simple. So let's hit the first one, then we'll talk about the next one. So first I will say QOR plus QOP equals 180 linear pair. So QOR is unknown, QOP is 100 equals to 180. So therefore QOR becomes 80. And then we will use angle at the center. So QOR double of QTR. So you can state angle at the center double the angle on circumference. So QOR 80 divided by 2. I will get my first part, that is angle QTR as 40 degrees. Put a box. So this is 40 and this is 80. So we managed to get the first one. Now the next one, QRP, which is here. Come on, same angle at the center and circumference. So QOP double of QRP, angle at the center double the angle on circumference. So QOP is 100 divided by 2 is QRP, and therefore I can say QRP is 50. So we get our second part, QRP. Now for the third part, QRS, that's this full. I know this is 50, 20. If I get this, I can add parallel. So alternate angles 40. So we'll first write alternate and then we will add everything. So step 10, angle SRT equals to angle QTR equals to 40 alternate angles. And therefore finally I can say QRS is equal to 50 plus 20 plus 40, so 110. So I got my third part as well, 110. Finally STR, which is here, STR. So how will I get that? So this full we got 110, this full will be 70, opposite angles of cyclic quadrilateral, and then subtract 40, you will get this 30. Let's write. So angle QRS plus angle QTS 180, opposite angles of cyclic quadrilateral. So QRS 110 plus QTS 180. So finally I will get angle QTS as 70. Final part STR 70 minus 40. Step 16, therefore STR 30 degrees. Oof. Good question from prelim point of view. You should get these sums. I would recommend each one of you, if you are getting the sums on your own, great. If not, you must watch the video twice, thrice. Only then you will get a good hand on it. These are all good questions. This is the most important question. Put a star beside it and give me your 100%. Otherwise, it's going to be very difficult. Firstly, they want you to prove BAP equals to ADQ. They have given you AQ parallel to BC and O is the center. Only two things given. So pay attention to me carefully. Step by step we'll go. Don't go ahead. Otherwise you will get confused. PAB is equal to ABC. Yeah, Z is being formed. So alternate angles. So we prove this angle equals to this. Pay attention carefully. ADQ equals ABC. Can you tell me why? ADQ equals ABC. Very good property. Superb. Exterior angle of a cyclic quadrilateral congruent to its interior opposite angle. So exterior angle, this is your cyclic quadrilateral ABCD, equal to its interior opposite. And now if we connect these two, ABC gets cancelled in our head. What you have is PAB equals ADQ. PAB equals ADQ, the first part that we needed. Yeah, if you want to be more precise, write that is BAP. Because BAP, PAB both are same, that's what they asked. ADQ. So we managed to get our first angle. Yeah, these two, all three are equal. AOB, double of ADQ. Now AOB technically is double of this angle, center circumference, but this has to be double of this. That means we'll have to prove these two equal. How to prove these two equal? So again pay attention, there is a lovely connection. I will say PAB, the trump we are using now, ADB. PAB, ADB, can you tell me why? See, PAB, ADB, mountain valley, so angles in alternate segments. We got these two equal. Now look at 1 and 5. PAB gets cancelled and I will get ABC. No, not 1 and 5. We'll have to take 3 and 5. PAB gets cancelled. ADQ is equal to ADB. That means these two have become equal now from 3 and 5. And now what we will do is angle AOB, what we need is double of ADB. Angle at center, double the angle on circumference. AOB keeping as it is. And ADB, instead of that I will write ADQ. So from 6 and 7 we managed to get our second part. Wasn't that great? You're enjoying it? Very good. So 1, 2. Now the last one. ADQ equals ADB. Magic, already proved. ADQ equals ADB. So we already proved the third part, then we went to the second part. So once again I am recapping. I am taking in terms of X so you can understand. This is equal to this alternate. This is equal to this exterior equals to interior opposite. So these two are equal. That's the first part. Then we said this is equal to this angles in alternate segments. So both x, so these two also equal. This is double of this, so this is double of this since both are equal. So if both are equal, third part is sorted, and this is double of this, second part is sorted. Good question, not lengthy but a good question. Yeah, for your homework I want you to do sum number 19, 20, 22, 24, 25. Till then, take care, stay safe, pray for everyone, and be honest. Bye. 25 I am asking you to repeat because it is a good question. Alright.
Hope you had a lovely mathematics experience with the Rough Book, our learning companion.